Hello viewers, welcome to ICSE board class 10 physics. We are with numericals. This is episode numericals 9.3 and we are going to work out numericals on our chapter that what we are continuing with, that is electrical energy, power and household circuits. We have already completed 1 to 7 sums. Now we are going to continue further from 8th numerical problem. So here you see there is an example done for us, and then we'll start with practice problem 8. I am going to solve question number 1, 2 and 3. You have to solve it. Calculate the current flowing through a nichrome wire immersed in 100 grams of oil at 20 degrees centigrade such that final temperature of oil rises to 80 degrees C in 5 minutes. So in 5 minutes it is going to rise to 80 degree centigrade. When supply of EMF is 10 volts, so it is 10 volts. So we have 5 minutes, so you have to convert into seconds. Okay, what is given? So potential difference is given 10 volts. Current I we have to find out. Time is given 5 minutes, so multiply by 60, it is 300 seconds. Mass of oil is given as 100 grams and specific heat capacity is given as 0.85 joules per gram degree centigrade. Theta rise, that is from 20 degree to 80 degree it is rising, so 80 minus 20 is 60 degree centigrade. Energy produced by the wire is IVT, so it is power. P is equal to VIT, or you can say IVT. So placing the value of V and T, we get I multiplied by 10 multiplied by 300, and energy absorbed by the oil is MC theta R 100, 0.85 and 60 joules. By the law of conservation of energy, we put energy produced by wire is equal to energy absorbed by the oil. So I multiplied by 10 multiplied by 300 is equal to 100 multiplied by 0.85 multiplied by 60. So we get the value of I as 1.7 ampere. So this is the way we are going to solve the following sum. So I am going to solve question number 1 from practice problem 8. Question number 2 and 3, that will be your homework. So I am going to solve this one. So let us start. Our answer begins from here. So here, practice problem 8.1. So practice problem 8.1. What data is given, that we are going to write one by one. Calculate the resistance of a nichrome wire. So we have to find out the resistance of a nichrome wire, capital R. So you put a question mark. Which will bring 200 grams of water. So mass of water is given how much? 200 grams. At 20 degrees centigrade. So theta V stands for temperature. So we have put T, that is 20 degrees centigrade. To its boiling point in 7 minutes. So time is given 7 minutes. 7 minutes, that means how many seconds? So it means 7 multiplied by 60. That is going to what? That is going to 420 seconds. Okay. Then when the current flowing through the wire is 4 ampere. So we will write down I is equal to 4 ampere. So we have got everything, the data is obtained. We have to find out capital R. So first of all we will work it out, the amount of energy used to increase the temperature of water, which is at 20 degree centigrade, and then we'll work it out the other things. So we'll start with amount of energy required. Energy required, right, is equal to what? For boiling the water. So that is what? MC theta R. So now what is M? 200 gram. Specific heat, that is given as 4.2 joule gram degree centigrade. So here multiply by 4.2, and here it says to its boiling point. So that means boiling point is how much? 100. So theta R, rising of temperature, that is from 20 to 100. So how much degree it has risen? It has risen 80 degree. So multiply by 80. So we got this one. Now here we are going to work it out, the energy given by the wire. So here we write, I am writing here, energy produced by the wire is equal to V I T, and this one both are going to remain same because of the law of conservation of energy. So here V is what, I is what, and T is what. Okay. So we got everything. We have to find out V from here. So here we go, we find out both of them are going to remain same by the law of conservation of energy. So here we get V multiply by 4, multiply by 420 is equal to 200 multiply by 4.2 multiply by 80. So we get V is equal to 200 multiply by 2 upon 10 multiply by 80 upon 4 multiply by 420. This one cancel, this one cancel, this one cancel, this one cancel, this one and this one cancel, this one and this one cancel. So what is the value of V? Value of V is 40. So potential difference we got is 40. That is our potential difference. Understood? Now it says we have to find out the R, resistance we have to find out. We know the current passing through the wire is 4 ampere. So now we have to, we know V is equal to what? V is equal to IR. What is V? 40. What is I? 4. What is R? That we have to find out. Therefore, R is equal to 40 upon 4. Therefore, R is equal to 10 ohms. So I hope you understood. I found out the value of resistance. If you have any doubt or any questions, please let me know, or you go through the video one or twice and you will be able to understand how to do the sum. Okay, let us move on to the next question, question number 9. So I don't think you have any questions related to this one, but this is the way we require to do the sum. Okay, we move on to question number 9. Question number 9. A battery of 24 volts and a negligible internal resistance is connected to a resistor of two resistors of 12 ohm and 6 ohm in parallel, and then to a nichrome wire of resistance 2 ohm immersed in 100 gram of oil with a specific heat capacity of 1.2 joules per gram degree centigrade at 30 degrees C. The current switch on is for 2 minutes. Draw the circuit diagram. Calculate the current flowing through the main circuit. So that is I in the main circuit. In the main circuit, current flowing through the 6 ohm resistor. So it is this one. And final temperature of the oil we have to find out. EMF is 24 volts. Internal resistance R is negligible, so 0. Mass of oil is given as 100 grams. Specific heat capacity of oil is 1.2 joule per gram degree centigrade. Initial temperature is 30 degree. Time is 2 minutes. That means 120 seconds. And we have to find out final temperature of the oil. We have already, the theta R is the temperature rise of the oil. So now we have drawn the diagram. After drawing the diagram, we have to find out the resistance of parallel as well as the series, because these two are in parallel and this one is in series. So 1 upon 12 plus 1 upon 6 plus 2 ohm. So 1 upon 12 plus 1 upon 6 is 3 upon 12 is equal to 1 upon 4. 1 upon 4 means RP is 4 ohms. So total external resistance, that is capital R, is given as 6 ohm. Now the current flowing, because it says question that in the question that we have to find out how much current is passing through 6 ohm. So I is equal to E upon capital R, right? Because it is through the external resistance we have got 6 ohm, that is capital R, but we have to take E because it is passing from the battery. The EMF is passing from the batteries of 24 volts. So here formula is like this: I is equal to E upon capital R plus small r, but small r is negligible resistance, so R is equal to 0. So E is equal to 24 upon R. Which R it is talking about? It is talking about the 6 ohm total external resistance. So here we have to find out the current passing through all of the circuit, so main circuit. So 24 upon 6 plus 0, it is going to give you 4 ampere. So we got the current passing through the whole of the circuit, that is the main circuit you can say, or you can say here from this one and this one. So that is 4 ampere. Now it says find out the amount of current passing through 6 ohm resistance. So we have found that current passing through this one and this one is 4 ampere. But it says how much current is passing through 6 ohm, that we have to find out. But first of all, we find out the potential difference across the parallel resistance only between these two. Why? Because 6 ohm is in the parallel connection. So V is equal to IR. Placing the value of I and R, we get 16 volts. Now from 6 ohm resistance we have to find out. So I is equal to what? V upon R. Volt is given as what? The potential difference in the parallel is 16 and the resistance through which it is going to pass is 6. So it is how much? 2.67. I hope you understood this one. The next one, if you see, it says we have to find out the energy flowing through a 2 ohm wire which is immersed in the beaker. So that means I square RT. I square is given, so it is 4 square because that is the current passing through the main circuit. So it is passing through 2 ohm wire also. So it is 4 multiplied by 4, that is 16. Resistance through of that particular wire is 2 and time is how many seconds? 120 seconds. So that comes up to 3840 joules. Now energy absorbed by the oil, because this one is in the beaker. This one. So this much amount of energy is required to increase the temperature of that oil. So 3840 is the joule, which is equivalent to mc theta r. Mass is given as 100. Specific heat capacity of the oil is 1.2. Theta r we have to find out. So when we solve, we get theta r is equal to 32 degrees centigrade, and if we add with the initial temperature with 30 degree, we get the final temperature 62 degree centigrade. 62.0, that is 62 degree centigrade. I hope you understood. If you have any doubt or any questions, please let me know in the question box. I am going to solve question number 1 from the practice problem 9, and you do the rest of the question, that is question number 2. Understood? Let us move on to the practice problem question number 9. So what I'll do, I'll put a column here and rest I will solve it in this side. So I'll start from here. Right? First of all, your answer. Let me put it down. So your answer. Practice problem 9.1. First of all, circuit diagram 9.3 shows 4 dry cells. So first of all, we will write down number of dry cells. Number of dry cells is how many are there? 4 are there, and each one with 1.5 volt. So total EMF will be what? EMF will be 4 multiplied by 1.5 volt, that is going to become 6V. So I got 6V. Internal resistance is given for each one. Internal resistance R is equal to 0.25 ohms. So for all of them it is going to be 1 ohm. So we got this one. Then it says 3 ohm wire is immersed in a 20 gram of water. So M, mass of water is how much? 20 gram. What is the temperature? Temperature is given, so theta T, I will write 20 degrees centigrade. The current is switched on for 6 minutes, so time is equal to 6 minutes and how many seconds? 36 seconds. So here 6 multiplied by 60 is 360 plus 36, that is going to be 396 seconds. 396 seconds. Reading shown in the ammeter that we have to find out, so I will write here. So we have to find out I question mark. We have to find out the current I passing through 1.5 ohm wire in a parallel one, and we have to find out the final temperature. So I will write down final temperature straight away, or you can say theta Ft. So that is final temperature. So these three things I require to find. So let us start with first of all finding out the resistance. Okay, so we'll find out resistance. External one, no? So that is capital R. Okay. So 1 upon Rp is equal to 1 upon 1.5 plus 1 upon 3. Right? Okay. So this becomes what? Here 2 plus 1 upon 3 is equal to 3 upon 3 is equal to 1. So Rp is equal to 1 ohm. Now total external resistance is equal to what? 1 plus 3. That is going to become what? 4 ohm. So I got total external resistance is 4 ohm. I have to find out the current passing through the circuit. So current passing through the circuit, I will say I is equal to E upon capital R plus small r. What is E? E is the EMF. How much you are getting EMF? 6. Capital R is here. Find out where is capital R? Okay. Capital R. Capital R external resistance, that is 4, and internal resistance is 1. So you got 6 upon 5. So I got 1.2 amperes. Okay, so that is done. So reading shown in the reading shown by the ammeter is how much? 1.2. So 1.2 ampere current is passing through the whole of them. Now what will go for? Will go for potential difference. So now V is equal to IR. I is given as 1.2 and R is throughout the whole circuit is how much? 4. So that is come up to 4.8. So I got V. So potential difference across. Suppose if I say potential difference across the parallel, because 1.5 is across the parallel one. So this is volt throughout the whole of the circuit, because I have taken resistance for the whole of them. So here I have taken main circuit. This one is the main one. But if I go for the parallel one, so parallel I require. So parallel I will take V is equal to IR, where I and the parallel resistance is 1. So I can replace it by 1.2 and 1. So it is what? 1.2. So I got the volts here. So I got the volt here 1. Now passing through, current through 1.5 ohm. So I have to find out. So now V is equal to what? IR. V is how much? 1.2. What is I that we are required to find out, and resistance is 1.5. So I is equal to what? 1.2 divided by 1.5. Understood? So here when you divide 1.2 divide 1.5, so 1.2 divided by 1.5, you get 0.8 ampere. So this is my current that is passing through. This is passing through 1.5 ohm resistors in a parallel circuit. Understood? So this is about the half part of the sum, but still we require to find out the energy required to increase the temperature. एक मिनट, sorry, यहाँ पर yes, okay. So we still require to find out the temperature. अभी temperature तो find करना बाकी है, बराबर. तो यहाँ पे अभी अधूरा जो सम है वो कंप्लीट करना है हमें. मास कितना दिया है सॉरी मास कितना दिया है, तो वो सब तो फाइंड करना पड़ेगा. तो हम लिखते हैं एनर्जी रिक्वायर्ड, यहाँ पे लिखते हैं, बराबर, क्योंकि बहुत जल्दी हो रहा है. एनर्जी रिक्वायर्ड, बराबर, टू इंक्रीज द इज इक्वल टू व्हाट? एम सी थीटा आर, बराबर. ओके, मास कितना है? 20 ग्राम. स्पेसिफिक हीट, ये वाटर के लिए है, आपने पढ़ा था 20 ग्राम ऑफ वाटर बताया उसमें. देखो यहाँ पे कहाँ गया? 20 ग्राम ऑफ वाटर. तो स्पेसिफिक हीट ऑफ वाटर पता है 4.2 जूल. तो यहाँ पे आता है 4.2 जूल, बराबर. तो मैं लिख देता हूँ यहाँ पे C इज इक्वल टू व्हाट? 4.2 जूल ग्राम डिग्री सेंटीग्रेड. सो 4.2. एंड व्हाट इज थीटा आर? राइज इन टेम्परेचर, ऐसा कुछ बताया उसने, राइज इन टेम्परेचर. तो आप देखो राइज इन टेम्परेचर नहीं बोला है, लेकिन उसने बताया कि भाई जब 3 ओम वायर इज इमर्ज इन 20 ग्राम ऑफ वाटर एट 20, हमें राइज इन टेम्परेचर, फाइनल टेम्परेचर फाइंड करना है, बराबर. ओके, तो राइज इन टेम्परेचर नहीं बताया, तो ये थीटा आर वैसा का वैसा ही रहेगा, बराबर. नाउ व्हाट वी हैव obtained we have to obtain VIT, that means energy supplied by the wire. कहाँ पर वायर, कौन सा वायर है देखा आपने? 3 ओम का वायर अंदर डाला हुआ है वाटर के अंदर. तो हमें सप्लाइड बाय 3 ओम वायर्स, दैट विल बी व्हाट इज द फॉर्मूला फॉर दैट? I स्क्वायर RT लेंगे. समझ में आ रहा है? तो यहाँ पे लेंगे I स्क्वायर RT. I कितना करंट पास कर रहे थे, चेक किया आपने? 1.2. सो 1.2 multiply by 1.2, what is R? 3, and how many seconds? 396 seconds, बराबर. Now according to the law of conservation, by conservation law of conservation of energy, by conservation law, we get this one and this one both are same. So we get like 20 multiplied by 4.2 multiplied by theta r is equal to 1.2 multiplied by 1.2 multiplied by 3 multiplied by 396. So theta r is equal to what? 1.2 multiplied by 1.2 multiplied by 3 multiplied by 396 upon you get 20 multiplied by 4.2. So if you calculate, you get answer 20.36. So this is theta r. So final temperature we have to find out. So final temperature is equal to initial temperature plus theta r. So here this is 20 plus 20.36. How much it comes up to? 40.36 degree centigrade. This is final temperature. So we got our answer. So which are our answer? So we will write down the number. Now if you see, first question was reading shown by the ammeter, that is question number 1A. So here reading shown by ammeter. So this is my answer. Understood? Next one, the another one that I obtained, that one was 0.8. right? So this is one of my answer, this is one of my answer, and the another answer that I obtained is my final temperature. I hope you understood this sum step by step. If you go and if you do it properly, then it will be easy for you to solve, as well as it will make you understand about the concept very clearly, as well as your formulas will be powerful while doing this type of sums 2-3 times. So let us move on to sum number 10. This is sum number 9, and question number 2 will be your homework. If you have any doubt or any sort of questions, please let me know. I try to solve it out. Please do it 2-3 times, then only it will be easy for you to understand. Thanks very much, guys. I'll move on to sum number 10. Sum number 10, an electric kettle is rated at 200 volts and can bring a certain amount of water to a boiling point in 5 minutes. So you got PD, right? And within 5 minutes it is going to be at a boiling point. If it is connected to a voltage supply of 180 volts, calculate the time at which the same amount of water will be reaching to the boiling point. So it is comparison between 200 volts and 180 volts. So energy is equal to V square upon T R. Placing the value of V and T and R, right? Here we have to find out the value. So comparison is there. So how much is this calculated time required for reaching the boiling point? So here we require to find out the time. So here R we don't require, but still we have to put R as it is, right? So that is an external one. It is external circuit resistance is not given, so no need to worry about it, because you are having 2 volts, 200 volts and 180 volts. So E is equal to V square T upon R for 200 volts, and E is equal to V square T upon R for 180 volts. We have to find out the time. So we have to find out T. These R and these R, because is going to cancel, because the electric kettle is same, not different. If it would be different, then the resistance would differ as well. So by solving it, by comparing it, we find out the time. Understood? I'm going to solve question number 1. Question number 2 will be your homework. So let us move on to the question number 1 of practice problem 10. So we say answer practice problem 10.1. So first of all, we'll find out an electric kettle rated 250 volts. So and a certain amount of water is bring to boiling at in 8 minutes. So 250 volt and boiling point is for 8 minutes. Understood? Okay. And another one is at 200 volt. What time the water will come? So we have to find out. So same sort of a method. So here E is equal to V square T upon R, and here E is equal to V square T upon R. So now both of them are going to remain same. So these R and these R is cancelled. So V square 250 multiplied by 250 multiplied by 8 is equal to 200 multiplied by 200 multiplied by T. So this 200 and this 200 will come down. So T is equal to what? 250 multiplied by 250 multiplied by 8 upon 200 multiplied by 200. So this one and this one cancel, this one and this one cancel. Here 2 ones are 2 fours are 2 ones are and 2 twos are. Got it? Now here 25 ones are 25 fours are 2 ones are and 2 twos are. So what is remaining here? T is equal to 25 upon 2. That is nothing but what? 12.5 minutes. So I hope you understood the way to do question number 10. Thanks very much, guys. Practice this type of sum often, because these type of sums are likely to be asked in board examinations. Thanks very much, and thanks for your patience. I'll see you in the next episode with the rest of the sums. Thank you, guys.